Well, welcome everybody, and thank you for choosing this session. This session is going to be about best cases and project reports, and the first presentation in this morning will be given by Brian Panulla and Megan Kohler, and it's called Open Rubrics and the Semantic Web. So please, when you want.
Good morning. It's great to be here. This is my first time in Europe, so I'm very excited to be addressing you here. And my co-presenter, Megan. Just a little bit about us to start. We are from opposite ends of North America. I'm a long-time staff member at Penn State University. Before last year, around Open Ed 2009 time, I moved to Portland, Oregon. And Megan is still at Penn State in Pennsylvania, so that just gives you a little bit of geography. You know, I didn't know all that much about Spain geography when I came here, but this will give you a little bit of our contact information too. But Megan's going to start us off with some discussion about the rubrics.
So as Brian said, we are from Penn State University, and more specifically, we work for a more specialized unit at Penn State University called the E-Learning Institute, and we're dedicated specifically to the College of Arts and Architecture. And one of the things that we do in Arts and Architecture is we create online courses for studio classes. And so oftentimes when we say that, people are just like, what? How can you do that with a studio course? How can you put that online? Well, one of the ways that we can do that is actually through the use of rubrics. And so just a quick show of hands. Have any of you used rubrics before in your classes? Okay, so some of you. So there's some familiarity with rubrics. Well, just to recap really quickly for those who may not be as familiar with them, rubrics is just basically a grading tool that can assist instructors with communicating their expectations to students. And this is an example of a holistic rubric. And as you can see, there's basically 5 main categories. And the thing that kind of defines a holistic rubric is that those categories are the classification for the overall assignment. And then that actually is quite different from a rubric that I'm showing you right now, which is one that we use in our classes. You can't see it very well, but this is an analytic rubric. And the reason why it differs from a holistic rubric is the fact that you have more categories. So this actually extends quite far down the page, and you can have anywhere from 2 to 10 or more categories or classifications of criteria for students. And as well, with an analytic rubric, you can have varying levels. So in this one, you're actually seeing 4 different levels of achievement. If we would scroll further down the page, you'd see maybe 2 or 3 in different areas based on what the criteria is for that portion of the assignment. And just really quickly, some of the benefits that we ourselves have been able to observe from the rubrics is a consistency in grading. So instead of instructors having to kind of work their way through 100+ projects, and maybe the results that they get from the beginning is very different from what they end up with, this allows them to have their base criteria, which they can stay consistent amongst their grading all the way through. In addition, it creates efficiency in reviewing the students' work. A lot of times we employ TAs to assist the instructors, and if the TAs also have the same set of criteria to grade from, it just makes things a lot more consistent for the students, as well as making things more efficient in the standpoint that instructor can actually work through grading those assignments much more quickly because the criteria is right there in front of them. They don't have to start from scratch every single time they sit down to review an assignment. In addition, the rubrics that we have developed, they provide students with a very specific set of criteria, but in addition, we've allowed the instructors to have their own fields in which they can provide customized feedback to the students as well. So if there's an exemplary piece of work, the instructor can say, this is really fantastic, you should really do something with this, or you should put it in your portfolio for later on. And last of all, and one thing that's actually been really huge for us, seeing as how we're an arts college and we're dedicated to the College of Arts and Architecture, and therefore we end up providing a lot of general education courses to students, is the scalability. So typically with a studio course, you're looking at a cap of maybe 12 to 15 enrollments. We've actually scaled that to 100 plus. So that's been huge for us, and Rubrics have been very key in allowing us to do that. So now I'd like to turn it over to Brian.
So now we're entering the technical portion of today's program. So rubrics have been very common in education, growing over the last few years. They're also very common on the web. And the big problem that this brings us is they're mostly found on the web in presentational formats. Microsoft Word documents, PDF, Excel spreadsheets, sometimes PowerPoint, or very old school HTML, plain hard to software parse HTML. The ones that are not in these presentational formats tend to be in proprietary internal system formats. Several learning management systems have rubric modules, such as Angel is the one I'm most familiar with. And that's just an internal data representation, as any web application will have, that's backed with a database of some sort. And that sort of representation of how the rubric is modeled is not generally exported or shared outside of the system, except as one of these presentational formats, so Microsoft Word or PDF. And this poses a bit of a problem when you want to build software systems that might facilitate the grading process, that might use rubrics as the user interface metaphor, which is the way that this project got started. And if we're sharing a set of data, if we have some research data that we've collected, we don't take a screenshot of the spreadsheet and mail that as a GIF or a ping to our collaborators, right? We send a CSV file. We send some sort of raw data representation that can then be used for processing in software systems. And this project and this string of projects have really led towards a way to do that with rubrics. We want to have a true data representation of a rubric. So this is the first project. Some of you who may have seen me talk last year at OpenEd, my colleague Stevie Rocco and I had presented a way that we finished this project via crowdsourcing. Our unit was broken up and we were scattered amongst colleges when we were no longer deemed relevant. But we managed to finish this project to save a colleague of ours that was planning her PhD dissertation around its use. But the gist was that this was a way for faculty members to decide for themselves how they should proceed being prepared to teach online courses. And we used a rubric as the user interface metaphor. So the user would come and they would click on the different boxes to say that this is how I feel about the various criteria in the rubric. And it would pass customized feedback back to the user when they were done. So one of the nice things that we did when we built that rubric, we were building on some earlier work that was a rubric commingled with the software code that displayed it. So any developers in the audience will understand what I'm going with that there. You want to separate your data from your program code because you don't want to have to recompile your program just because you've changed the rubric. But that was the sort of situation where the software was in before we took on the project. So we broke the rubric out into an XML, very simple XML representation. And the idea being that you could just swap the rubrics in and out, but that software code would not need to change. And that got us pretty well to where we wanted to be. And then I started doing some work with the semantic web from some other research projects. So how many of you are familiar with the semantic web, sort of as Tim Berners-Lee would talk about it? Okay, good. There are a few of you. So this will be mostly to the rest of you, but we'll hit this pretty quickly. So 3 things the semantic web is not, in my opinion. Now, first, it's not semantic HTML. So for any of you technology people who have done web development, the term semantic HTML is very near and dear to my heart. We bootstrapped through the Zeldman book here, Designing with Web Standards, to relearn how to make HTML. I'm not talking about that. Semantic HTML is a bit of a misnomer, and it causes a lot of confusion. It's also not just warmed over artificial intelligence. So I know at least one person probably in the audience we've had this conversation. I'm not an AI guy. I did not come to this from the AI machine learning perspective. So that's not my take on this. Maybe in 10 years we might have some interesting things to talk about, but I'm not holding my breath for that. And it's also not magic. So any software system, you're really just shifting where you optimize, and it's just a different way of looking at building dynamic web applications, right? So this is not going to magically make automatic grading robots. It's not what this talk is about. So 3 main languages, RDF, RDF schema, and OWL. Plenty of information. This could fill several talks by itself. But mostly I'm working with OWL in the development of the ontology. And enough said about that. If you catch me later if you want to know more. So how I look at the semantic web is that it's infrastructure. The photo up there, this is a very American sort of perspective, and I'd be curious to hear if this is the same sort of development happened in other parts of the world. But we laid a rail system across the United States in the 1800s. And when the telegraph came along, we needed to string wires across the country to send information. Well, where did we run the telegraph wires? We ran them along the train tracks. The train tracks were our right-of-ways, and were already connecting all of the major metropolitan areas. So we took the infrastructure that was moving people and moving goods, and we laid an information network right along the pathways. And this is how I view the semantic web. What we're doing is we're building data pathways to move information using HTTP, the same mechanisms that we use to move people goods with e-commerce and human-readable content. So that's sort of my perspective. This cartoon, how many of you are familiar with XKCD? And again, maybe a little bit of a too much of an American thing, but it's this cartoon took the higher education web professional community by storm about a month and a half ago. And it basically says everything that we put on college and university websites is the kind of stuff that the people coming to the websites don't care about. The people coming to the websites care about content. They care about addresses, contact information for their faculty. What do they need to do to graduate? How do they apply to the university? And what do we put? We put marketing videos. We put brochures. And the stuff on the right-hand side is the semantic web. The stuff on the left is the human web. So that's all I can say about that. What we're doing is we're building linked data. We're building data sets that are linkable in the same way that human readable content is as HTML. And the linked data movement started, fairly early on. In 2008, each of these bubbles represented a different ontology, a different way of describing different sets of information, taxonomies, knowledge domains. So this is where we were in 2008. Here's where we were earlier this year. So we had a huge increase in the numbers and types of information that people are describing using these OWL, RDF, semantic web technologies. So we're kind of here now. The technologies are there and usable, not necessarily in every platform, every programming language, but as an open standard, things are growing. So through the process of this research, the project originally at Penn State, some stuff I've done on my own, and then later again with the eLearning Institute, I've developed an ontology for describing rubrics. And this is not really, we're not talking like machine learning here. We're not going to make robots that can grade assignments for you. But at least it's a digital representation of how to describe a rubric such that a software system can make a nice user interface and let people click on things to do their grading. So we've decomposed a couple of different types of rubrics, the analytic and holistic, as Megan had mentioned. There are a couple of other minor types that we're still sort of struggling with and how we would model those. And from the rubric down to the next level of information architecture, we've got criteria, we've got levels, scope, scoring, and so this is in the paper too. So if you're more interested about implementing this, talk to me or take a look at the slides or take a look at the paper. Some back of the envelope UML, all right, is I'm not a UML purist, so I know I've broken several laws in actually producing this chart, but this is a great way to communicate how I'm thinking about relationships. So again, if you're curious about how this works, take a look at the chart. But we'll go on to criteria. Criteria I view as the fundamental unit of the rubric, so that's generally, sorry, I'm talking with my hands. That's the rows. You will generally find the criteria modeled as rows in those tabular sort of rubrics. But you have to look very closely. Sometimes the holistic rubrics really mess with you because they're changing the presentation, but they're not changing the semantics of what they're doing. But so the criteria are modeled as rows, and the rubric is basically a set of criteria, ordered set, to be more specific. The criteria themselves are broken down into these levels of achievement, so you can think of those as the columns across the rubric. And so those represent how well a student may have accomplished a particular task, all the way from, did not complete assignment, as I got a lot when I was growing up, all the way through, exemplary or exceptional, or A+++++++. So this is all very flexible, but depending on how you grade, or whether you're doing assessment and not evaluation, sometimes it's not about the grade, sometimes it's a learning objective, and based on what level of achievement the person has achieved, you would want to give customized feedback, but not necessarily a grade. So, and then finally, the last big object is sort of categories. Some large rubrics were sort of unwieldy, just dealing with large sets of criteria, and we found it convenient to group them into categories, so you could make a set of criteria that were collapsible in a tab set or an accordion control. And the categories are merely aggregations of criteria, so nothing too complicated there. Again, data model if you want to take a look and absorb what's going on there. And finally, the two other sort of metadata concepts are scope and scoring. We wanted to make sure that every rubric that was produced according to this ontology would have denoting of how the creator was intending it to be used. So the scopes that we saw were individual. If you're evaluating an individual piece of work, individual student's work, are you evaluating a work of a team? Is it a peer-to-peer evaluation, or is it a self-reflective evaluation? And finally, scored versus unscored. For those of you that are in assessment know that sometimes unscored, you don't want to actually score things. You don't want things to be part of a grade, but you want to have that opportunity to provide feedback on the assignment. So integration points. Friend of a friend is a common way of describing people in relationships. The Creative Commons RDF, these are ways that things that we've already planned to integrate into the rubric ontology, but we're not going to try to duplicate this because these are some of those bubbles that are in the massive graph that are out there for us to leverage. Finally, Dublin Core is another possibility. I put a question mark there as I'm not a metadata guy, I'm a data guy. So anybody in the audience that is interested in collaborating with this, and if you're more up on the minutia and the critical pathways through Creative Commons or Dublin Core metadata, I'd love to talk with you. We finally, no software spec is good without a reference implementation, and we have built, and this is the current project that I'm working on with eLearning Institute at Penn State, is a builder. It's in Adobe Flex, it's in Flash. We have some JavaScript libraries that are doing similar things, but for right now, the most expressive UI in Builder is in Flash and Flex. This will be open sourced for anybody that wants it and can tolerate ActionScript. But again, I'm not worried about the technology at this point. I'm proving the ideas about how to build rubrics. And we have a Drupal 6 module that uses the old schema, and we're working on a Drupal 7 module that's going to use the new ontology semantic web-based technologies, because Drupal 7 has full support for the semantic web sort of built in off the shelf. There's some links to the projects that are currently published. I have posted the rubric ontology definition files to my GitHub account. So if anybody that's public, that's out there, if you want to pull, clone, fork, send me patch requests, let's talk about it. The rubric builder is going to be open sourced. It's in a Mercurial subversion or Mercurial source controlled repository. So once I figure out how to get that into maybe GitHub or some better ways to share it, we'll publish the code to that. And as I said, a Drupal 7 module is forthcoming. But the Drupal 6 module doesn't use the semantic web technology, but it is available as an add-on on Drupal.org. So, and you don't need to see the backup. So that's the, there's lots of slides on RDF in there that I wasn't going to bore you with. Hopefully I didn't speak too quickly, but that's our presentation on the rubric ontology, and I guess we can do questions.
Thanks. So inasmuch as you talked about linked data, And then you talk about these rubrics and the individual components of the rubric, whether they're the categories or the feedback or the score. What opportunities are there to make useful links between this rubric data and other kinds of data? So are you thinking that if in a certain category, if I've achieved a poor score, that maybe I link that feedback back to some part of content somewhere else I can remediate if I've had a problem? You talked about linked data, but then you didn't talk about what you're going to link the rubric to. So where are the opportunities here?
The best example that I've seen, and I've talked with some other people to do this sort of aspect. The low-hanging fruit would be to reuse feedback, and as you would go and grade a student's work, if you collected the custom feedback that you're entering all the time, you select a certain level of achievement for a certain criteria, and you're prompted for feedback that is coming from a repository. So those sort of the feedback databases get syndicated and allow the graders to reuse that sort of information. To link them with assignments, certainly from an LMS sort of perspective, where you're posting your assignments in a concrete place, you want to attach the rubric to it. The linking back to the content elements and the learning objectives is a fairly valid idea. Where I see the fundamental sort of atomic piece of the rubric is the criterion. So breaking down the levels are not necessarily all that useful outside of the criterion, but for the semantic web folks, I've pictured the levels as having blank nodes and not actual URIs, but the criteria as having URIs, and the rubrics having a URI as a collection of criteria to allow that level of interlinking between the other data out there in the cloud.
Yeah, I've got two comments. One's a follow-up to David's question. I think what you link to fundamentally is you should be linking to examples, authentic examples of people who've got it right or are illustrating that level. Because fundamentally, what I find in some of the courses that I teach, where the rubrics have been designed by instructional designers or other faculty members or people I just generally don't agree with, is that there's no examples for them to follow. And people, you get into a situation like riding a bicycle. Well, you've got an example. You can see somebody riding a bicycle properly, and that's the model you work towards. But if you've got an abstract dance step in the arts, or you've got a complicated paper or a piece of computer code to write, you want to, what does it look like when it's done right? So that's the first thing that you should be linking to. The second comment relates to rubrics that I don't like. And I find that there's almost too much use of rubrics in instructional design and design. And I think you mentioned there were two kinds of rubrics, Megan, and I'd like you to elaborate a bit more on the algorithm. Was it algorithmic, or what did you call it? The analytic and the holistic. Because when I look at rubrics and I go to do marking, and I've got a stack of papers yay high, and I look at my watch, and I've got to get through them all in 15 minutes. The first thing that goes out the door is that rubric, and they're very useful, I think, for students to follow when they're putting something together. But as a marker, I'm looking usually for something more conceptual, and I want to use the holistic approach because I sort of say, well, you've got your rubrics, but I've got an A, B, and C, and so C is like I wouldn't give this to a dog. B is you can get by with this, it's got its flaws, and A is it sails through and gets the seal of approval. Anyway, maybe you'd like to elaborate on the difference between those two types of rubrics for us.
Well, one thing that I would like to touch on is the fact that you had mentioned that you would like to see us linking to examples. And that's actually one of the things that we have done. In the design of our assignments, we actually provide the students with a full set of instructions on how to complete the assignment. Then we provide them with examples of other student works in the course so that they can see that, it may not be as big of a mountain as they think it is to create this elaborate assignment, that there's other students who have done it, and there's other students who have done it very well. In terms of the analytic versus holistic, one of the things that we've really strived for in creating our rubrics is the usability for the instructors, because we do understand that their time is limited, and especially if we're taking a course from 12 students to 100 students, that's a huge impact for them. So one of the functionalities that we have with the rubrics is that the instructors can have the rubric open and look at the assignment at the exact same time, and they can literally just click right through. And it just reduces their grading time substantially. Now, we don't actually use holistics rubrics that much. We mostly focus on analytic rubrics. But if you'd like to talk about the differences between those two, maybe we should talk about that afterwards, because I know we're a little pressed for time.
Yeah, and I would really like to hear somebody that uses a holistic rubric and can adequately discuss that with me, because I'm having trouble finding people.
Okay.